Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, it is time to continue further with Mathematics class 11th, and the chapter that we are going to deal today is straight lines. We'll be beginning with the exercise 10.1, and the exercise 10.1 is based on the basic concepts of straight lines which are related to, for example, something related to distance formula, section formula, area of triangle. These are some simple concepts which I have studied in the previous classes. Other than that, in this particular chapter, exercise 10.1 also includes questions related to finding slope of line, angle between lines and such kinds of things. Right, some simple formulae have been covered in the theoretical part of this chapter, this particular exercise. You can go through those theory, or we'll be also discussing the theory points along with our discussion over here with all the questions one by one. Let's see the first question. Question number 1 says, draw a quadrilateral in the Cartesian plane whose vertices are this, this, this and this, also find its area. Now how will we deal with this one? So the first thing the person says is to draw a quadrilateral in the Cartesian plane. So let's first draw a rough Cartesian plane in this manner and see where does that take us. So you have minus 4, 5, 0, 7, okay, we'll need 7 over there, you have 5, minus 4, 2. Okay, you'll need a lot of points. Let's mark those points. 1, 2, 3, 4, 5, 6, 7 is will be required over here. In the negative, will require up till minus 4, minus 5 actually. 3, 4, 5, maybe 6 as well. And the positive side 1, 2, 3, 4, 5. And here you'll have minus 1, minus 2, minus 3, minus 4, minus 5. Let's say these are the points. Okay. Can we mark them? Yes. 1, 2, 3, 4, 5. These are there. This is minus 1, minus 2, minus 3, minus 4, minus 5. This is 1, 2, 3, 4, 5, 6, 7. And correspondingly you have minus 1, minus 2, minus 3, minus 4, minus 5 here as well. Okay. What next? Minus 4, 5. Now where will this point lie? Minus 4, 5 will lie at this location. Minus 4, 5 will be somewhere here. This is the location of minus 4, 5. Okay, the next point 0, 7. 0, 7 will be located here. This is the point 0, 7. 5, minus 5. 5, minus 5 will be located here. This is the location of 5, minus 5. And minus 4, minus 2. Minus 4, minus 2 will be located over here. This is the location of minus 4, minus 2. Let me mark the points once again. But this is minus 4, 5. This is 0, 7. This is 5, minus 5, and this here is minus 4, minus 2. So that's the quadrilateral. Those are the vertices of the quadrilateral. Let's join them to finally give us this. This will be a straight line, yes. This will pass through this point, and then we'll join these 2 points in this manner, and then we join this also in this manner. This is what you get, right? Oh, does it pass through 3? Maybe. Let's see. So what all do we have? We have drawn the quadrilateral whose vertices are this, 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 and this. There's another part to this question that says that also find its area. Now how are we supposed to find the area of this quadrilateral? If you are aware of the ladder method, then you can easily solve for the area by taking all the vertices of any polygon. Here we have a quadrilateral, and we can simply find area using one simple concept of ladder problem. What does it say? Half times. Okay, write all the vertices in a anti-clockwise order first of all. Okay, write all vertices in anti-clockwise order. You can begin from any one. Let's begin from 0, 7. 0, 7. Next will be in the anti-clockwise order will be minus 4, 5. This is using the ladder method, mind you. Minus 4, minus 2, and 5, minus 5. This is what you have. Then the first point is repeated again. 0, 7 will be repeated again and written in this manner. This is what you'll have. Okay. Now what are we supposed to do? You're simply supposed to cross multiply this, each terms actually. This is what you're supposed to do. This is half times. What you have will be, these will be positive terms, and these will be actually terms with a minus sign. So what you'll have is 0 plus 8 plus 20 and plus 35 minus, you have minus 28 which will become plus 28, minus 20 will become plus 20, minus 10 will become plus 10. This is what you'll have, and minus 0 will become plus 0. This is what you'll have. Okay, the area will come out to be this particular value. What is that? This is, let's see, this is 35 and 28 and 20, 20, 10. This is 50, This is 28 and 8 will be 36. 36 and 35 will be 71. 71 and 50 is 121. So this is actually 121 upon 2, and the area will be actually square units. This is what you'll have, right? This will be the area, but this is using the ladder method, okay? When you consider from the point of view of NCERT, you would say, sir, ladder method is not covered. How will we find the area without the ladder method? So the answer is pretty simple. You know how to find the area of a triangle, and a quadrilateral is nothing but made up of two triangles. Can you observe that we can pick up maybe this triangle? Let's join these, and this becomes a triangle, this becomes another triangle. So this is area A1, this is area A2. We can find areas A1 and A2 very easily with the help of concepts of area of triangle, right? And how do we find that? Once again, one of the approaches for finding area of triangle is again this ladder method. This ladder method works for triangle as well, right? The only thing is you'll get only 3 vertices, you'll repeat that 0,7 again. That's what you'll do, right? Ladder method works in that case. Another approach could be to use the determinant x1, y1, 1, x2, y2, 1, x3, y3, 1 determinant and multiply it with half. That's another approach that you can follow. Or since the determinant is not covered up till now for you if you are in class 11, so what you'll need is the approach which is given in the NCERT directly. I'll follow that approach now. So area for a triangle having vertices x1, y1, x2, y2 and x3, y3. The area of a triangle having this many vertices will be delta is equal to half, and you get x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. This is what you get. And at the end only consider one more thing. What is that? That x1, this particular value may come out to be negative. This particular value may come out to be negative, but area is always positive. So you'll have to take the absolute value of this expression. Okay, you'll have to take the absolute value of this expression if this value comes out to be negative. And when will this value come out to be negative? Actually, if you consider the vertices in clockwise order, this value comes out to be negative. Oh. So we should always consider vertices in anti-clockwise order. Yes, you should always do that. Preferably, right? Let's focus on finding the area A1 first. This is alternative. Using this formula, let's find A1. A1 will be equal to half times A1. A1 is this, right? Considering anti-clockwise order, let's begin with this. This formula says x1. x1 is 0, let's say 0 times y2 minus y3, okay? And 1, 2 and 3 is what you will get, right? Anti-clockwise order. So y2 minus y3 will be 5 plus 2. This will become 5 plus 2, okay? Plus x2. x2 is this, which is minus 4. Minus 4 times y3 minus y1. This is what you get. Minus 2 minus 7. This is what you will be getting, okay? And then you have x3, which is minus 4 times y1 minus y2. y1 minus y2, which is 7 minus 5, 2. This is what I'll be getting, okay? This is half, which is okay. And this is 0. This is 9 times 4 is 36. 36 minus 8 is 28. This is what I'll be getting. Right? 36 minus 8 is 28. This becomes 40. That's what you get. This is area 1, A1. What about area 2? Let's find area 2 as well. Area 2 will become half times. Let's consider the vertices in anti-clockwise order once again. So let's begin with this x1, y1, this is x2, y2 and this is x3, y3. Let's consider that. And x1 will again become 0, y1, y2 minus y3 is not important, this will become 0. Plus x2, x2 is this minus 4. And y3 minus y1, y3 minus y1 is minus 5 minus 7, which is minus 12, okay. Then you have x3, x3 is this 5. Times y1 minus y2, y1 minus y2, which is 7 plus 2, which is 9. This is what you get. And what is this overall equal to? 12 times 4 is 48 plus 9 times 5 is 35. This is what you are getting, yes. So 12 times 4, 48 and 9, 5, 45 is actually 45 and 48 is 93. this becomes 93 upon 2. Okay, the total area of the quadrilateral, will be equal to A1 plus A2. What is that? This is 93 upon 2 and the other area is 14. So this can be written as 28 upon 2. This becomes 93 plus 28. What is that? 121 by 2 square units. Let's write square units, and that's your answer for this question over here. So this is using the idea of NCERT, and this is if you are aware of something called ladder method. Okay, that's what you have. So that's the complete solution of this question over here. The second question says, the base of an equilateral triangle with side 2A lies along the y-axis such that the midpoint of the base is at the origin. Okay, find vertices of the triangle. Pretty interesting. We have to draw the Cartesian plane first of all. Let's draw the Cartesian plane. These are the x and y axis respectively. This is the origin. Okay, base of an equilateral triangle with side 2A lies along the y-axis. Such that the midpoint of the base is at the origin. So base is this, and the midpoint of the base is at the origin. So the total length 2A will be divided A above and A below. So let's mark this will be the base, right? This will be one end point and this will be one end point of the base. Okay, find the vertices of the triangle. Now for the vertices, what we'll need is, we'll need another vertex, right? This is the base. So for an equilateral triangle, what do you have? You need 3 vertices. If you are aware of the base, then you only need this much, right? The coordinates of the base, the endpoints of the base 0, a is what you'll have over here, since this distance is a and this distance is also a. This will become 0, minus a. These will be the coordinates of a and b. Okay. For forming the triangle, what do you need? For forming the triangle, you need another vertex, and for an equilateral triangle, you can observe that the next vertex will lie. If this is the base, then you can draw this perpendicular bisector, and the vertex will lie on that perpendicular bisector, right? So perpendicular and bisector will be this x-axis. You can clearly observe that, right? That's pretty simple. And once you observe that, you can say, okay, the next vertex can be here. Okay, you can have a vertex over here in this manner, and this will be an equilateral triangle. But then, can you also have another vertex maybe there and get a totally different equilateral triangle? Yes, you can. With the same base, we can have a vertex here as well, and we'll get this equilateral triangle. Oh, is that so? Yes, this is so. So possibilities of C are 2. This is C1 and C2 are 2 possibilities for the vertex C to give you possible equilateral triangles in this manner. Okay. What are the special things in this? Basically, this particular angle is known to us. This angle is angle of the equilateral angle. This is 60 degree, right? Or you can say pi by 3. Okay. Once you are aware of this, you can use simple ideas of trigonometry to find the coordinates of this C1 with the help of this length over here, right? This is what you'll be doing. How do we do that? So for that, simple concepts of trigonometry, yes. And if you observe, if this length over here, if this coordinate is, let's say, since C1 lies on the x-axis, let's call this coordinate as h, 0. Okay. If this is h, 0, this distance over here will be simply h. Okay. This distance over here from O to this vertex A is simply small a, which we are already given. And if you consider this right angle triangle with this angle 60 degree, you can observe that tan of this 60 degree will be this upon this, right? Imagine this, tan of 60 degree will be perpendicular upon this. Okay, so I can write tan 60 degree is equal to h upon a, and that tells me that tan 60 degree is √3. This becomes h upon a, and which tells me h is equal to a √3. Okay, this is what you have. So with the help of this, I can say that the coordinates of C1 will be, the coordinates of the vertices of triangle can be A, which is a, 0, B, which is minus, sorry, just a minute, not a, 0, it is 0, a, right? 0, a, 0 comma minus a. These are the coordinates, and the coordinate of vertex C will be a root 3 comma 0. This is what you'll have. Is that okay? Yes. What about coordinates of this C2? This distance will again be h. Okay. And the coordinates of this will be minus h comma 0 actually. Yes, that is what you can observe. And a similar calculation will tell us that this or a 0 comma a, b 0 comma minus a, and c minus a root 3 comma 0 will be the coordinates of vertices. This or this. Both the answers are correct for this question since nothing else is given to differentiate between these two. Right, midpoint of base is at the origin, find the vertices of the triangle. That's a complete solution for this question. Let's talk about the third question, which says find the distance between P x1 y1 and Q x2 y2 when PQ is parallel to the y-axis, and second part PQ is parallel to x-axis. Okay, when the line segment PQ becomes parallel to x-axis or parallel to y-axis, you can maybe guess something about x1, x2 and y1, y2. Maybe you can get something related to that. How will we do that? Let's talk about this. The first part. For the first part, what do we have? PQ is parallel to y-axis. Okay, if PQ is parallel to this y-axis, let's say point P is here, point Q will be somewhere here. It can be here as well, but point P and Q will be in this manner, right? Point P is x1 comma y1, point Q is x2 comma y2, and if this becomes parallel to the y-axis, you can clearly observe that x1 will be equal to x2. That's what you can observe, right? That is, since this particular PQ is parallel to the y-axis, the x coordinate will remain same, right? If the x coordinate is same, then distance of PQ, the length PQ, which is equal to under root of x1 minus x2 whole square plus y1 minus y2 whole square. We are simply applying the distance formula. This is equal to this. x1 minus x2 will become 0. Okay. And this is y1 minus y2 whole square. We cannot comment anything about this. This remains as it is. Okay. Under root of y1 minus y2 whole square. What is that? Under root of x square. And what is square root of x square equal to? Mind you, it is equal to mod x. Right? This is something which you should be aware of, which you should remember. It is not plus minus x, it is mod x, right? This value is always positive. This should be always positive, right? So this becomes y1 minus y2 and its modulus. We'll not write it as plus minus y1 minus y2. This is it, right? If y1 is greater than y2, this becomes y1 minus y2. If y2 is greater, this becomes y2 minus y1. The final output that you'll get over here by substituting any values of y1, y2 should be positive, non-negative, or precisely non-negative for that matter, right? This is what you have. So this is the first part when PQ is parallel to the y-axis, and now you can easily guess for the second part what you'll have is, if PQ is parallel to the x-axis, what you'll have is this is point P and this is point Q, let us say. If PQ is parallel to the x-axis, the coordinates x1 comma y1 and the coordinates x2 comma y2 will have a condition. What is that? If this is parallel to the x-axis, the y coordinate will be same. That is, y1 will be equal to y2. Here y1 equals y2. This is the important thing. Therefore, PQ, the distance PQ is equal to what? Now, seeing this calculation, you can observe, yes, it will be modulus of x1 minus x2. But let's write again, x1 minus x2 whole squared plus y1 minus y2 whole squared and its under root. This is the distance. And that second term becomes 0. So this becomes under root of x1 minus x2 whole square, and which is equal to modulus of x1 minus x2. This is what you'll have. That's PQ for us in this second part. When PQ is parallel to the x-axis, this is the distance. Modulus is important. Modulus is important, right? The value has to be non-negative. Value has to be non-negative. That's a complete solution of this question over here. The fourth question says that find a point on the x-axis which is equidistant from the points this and this. Point on the x-axis, okay, which is equidistant from this and this. So let's consider the x-axis first of all and observe any point on the x-axis will have some particular type of coordinates. What is that? This point is on the x-axis and this will have coordinates h comma 0. Any point on the coordinates, for any point on the x-axis, the y coordinate will be 0, right? The ordinate will be 0, you can say, and the abscissa can be anything for that matter, right? So we are focusing on this h basically, and the condition that is given us that equidistant from the point 7, 6, okay, let A 7, 6 and B 3, 4 be the given points, okay. Let P h, 0 lie on the x-axis. Let this point be on the x-axis, okay. Therefore, the condition that we have is that distance of P from A is equal to distance of P from P. Point on the x-axis is equidistant, same distance. That's what you're supposed to do, right? And once you write this, it becomes very simple after that. What you simply say is, okay, this is PA, which is under root of x1 minus x2 whole square, which is h minus 7 whole square, plus 0 minus 6 whole square, which is 6 square, under root of PB, which is h minus 3 whole square, plus 0 minus 4, which is 4 square only. This is what you get, right? And since you have under roots on both sides, let's square and see where does that take us. This becomes h square minus 14h plus 49 plus 36 is equal to, this becomes h square minus 6h plus 9 plus 16, okay, squaring and then expanding as well. So you see that h square gets cancelled, okay, and what else remains? This 14h will go over here and this becomes 8h, okay, 14h minus 6h becomes 8h, and 49, 36, and here you have 25 will come over here, this becomes 11 plus 49 is 60 is what you get, and this tells me h is equal to 60 upon 8, which can further be broken down into h equals 15 by 2. So point, therefore point P will be 15 by 2, 0. That's my correct answer for this question over here. Point on the x-axis which is equidistant from the 2 points is this point, right? That's the solution for this question. The fifth question says, find the slope of a line which passes through the origin and the midpoint of the line segment joining the points this and this, okay. Slope of a line is being asked which passes through the origin, okay. Let's try to mark these points. The origin is 0, 0. This is what you can observe, okay. And joining the midpoints of 0, minus 4. 0, minus 4 will be somewhere here, okay. Let's call this P. 0, minus 4, and B is 8, 0. Let's mark B over here, 8, 0, okay. Slope of a line which passes through the origin and midpoint of the line segment. Midpoint, the midpoint is important, right? Midpoint of this line segment over here. Midpoint will be somewhere here. Let's call that midpoint Q, okay. And the coordinates of Q can be found very easily. That will be x1 plus x2, 0 plus 8 by 2, x1 plus x2 by 2. Midpoint is x1 plus x2 by 2, y1 plus y2 by 2, minus 4 plus 0 by 2. And what does that give me? This is 8 by 2, which is 4, minus 4 by 2, which is minus 2. This is the midpoint, right? And next we are asked to find the slope of this particular line joining this and this, okay. So slope of any line is actually equal to y2 minus y1 upon x2 minus x1 for points, for let us say lines, for any line connecting x1 y1 and x2, passing through x1 y1 and x2 y2, right? If this is a line, then the slope is given by this formula. So slope of OQ over there will be equal to what? For OQ, you will have y2 minus y1, which is minus 2 minus 0, and x2 minus x1, which is 4 minus 0. Oh, we could have taken x2 y2 as this as well. So in that case, you will have to do 0 minus a minus 2 and 0 minus 4. That will give you the same result, right? You don't have to worry about that. This is what you are getting, and what is that equal to? This is minus 2 upon 4, which is minus 1 by 2, and yes, that is the answer for this question over here. That is the final solution, yes. So you were asked the slope and you have found the slope in this manner. The sixth question says that without using the Pythagoras theorem, show that the points this, this and this are the vertices of a right angle triangle. Now, for a right angle triangle, when you are given the vertices, the easiest approach for proving that a triangle is right angled is that you can find distances of sides, and you see that AB square plus BC square, if it is equal to AC square, if it is equal to AC square, then the triangle will become right angled. But the person says, okay, do not use the Pythagoras theorem, you are not supposed to use that idea. So what else? Do we have any other idea? Yes, maybe. Since we have studied slope now, we know that for a right angle triangle, this angle has to be 90 degree, right? And in that case, if this is line AB, the slope of AB can be found and the slope of BC can be found. So an alternative condition could be that M of AB times M of BC. Now slopes of two perpendicular lines, the product is equal to what? The product of slopes of two perpendicular lines is simply, yes, please guess, -1. And if this becomes -1, then you can say that this angle here is 90 degree, right? If this becomes -1, that's the other approach, and that is the approach that will be following for this question. So without using the Pythagoras theorem, show that the points this and this are the vertices of a right angle triangle. I don't know the angle, which angle will be 90 degree. So I'll have to find the slope of all the possible lines. Let's mark the points first of all on the Cartesian plane and see where do the points lie. This is 4, 4 will lie somewhere here. Okay, 4, 4. Then you have 3, 5. 3, 5 will lie somewhere here. This is 3, 5. And then you have -1, -1 will lie somewhere here. -1, -1. Pretty interesting, right? Yes, this and this and this. Okay. Still, can you guess which angle will be 90 degree? Probably this one or this one. This is not supposed to be 90 degree. And if you are able to guess very well, the angle formed at this 4, 4 will be 90 degree. But then how do we ensure that? There's no way to ensure that as such. Let's mark this vertex A, this vertex B and this vertex C. Let's call this vertex A, this vertex B, this vertex C. And now let us try to find the slope of the three lines and see if the product of slope is -1 in any case. Let's see. So first I'll calculate M of AB. Now slope of any line joining x1, y1 and x2, y2 is given by y2 minus y1 upon x2 minus x1. So for AB you have 5 minus 4 upon 3 minus 4. What is that? 1 upon -1, which is simply -1. This is M of AB. What is M of BC? M of BC will be equal to y2 minus y1, which is 5 plus 1 upon 3 plus 1. What is that equal to? This is 6 upon 4, which is 3 by 2. What about the slope of AC? Can you find the slope of AC as well? Yes. This will be equal to 4 plus 1 upon 4 plus 1. What is that? 5 upon 5, which is 1. Okay. And from here, can you observe, since you observe that AB and AC, the product of these two slopes, this 3 by 2 will create a problem, but the product of this and this, M of AB times M of AC is equal to -1 times 1, which is -1. This tells me that AB will be perpendicular to AC, which implies that if AB and AC are perpendicular, therefore this particular angle, which implies that angle A is equal to 90 degree, and this tells me that triangle ABC is right angled triangle. That's what you wanted to prove. Are the vertices of a right angled triangle? That's what you wanted to prove. That's the complete proof of this one. So instead of using the distance formula, we have used concepts of slope in this question over here. That's the 6th question for you. Let's talk about the 7th question, which says find the slope of the line which makes an angle of 30 degree with the positive direction of y-axis measured anti-clockwise. Pretty interesting. We are given inclination in some way, right, which makes an angle of 30 degree with positive direction of y-axis. Okay, but the inclination is not directly with respect to positive x-axis. It is given in some other way. Angle of 30 degree with the positive direction of y-axis, anti-clockwise. From y-axis you go anti-clockwise, an angle of 30 degree. So this is what you have, right? this particular angle is 30 degree. That's what the person has said. Okay. Positive direction of axis measured anti-clockwise. This is y, this is x, and the slope of the line, which makes, we are supposed to find the slope. Now for the slope, the angle that you need is this particular angle. If this is theta, then slope is equal to tan theta. That's what I am aware of, right? With respect to this positive x-axis, the angle measured anti-clockwise is theta, then the slope becomes tan theta. And if, can you find this theta somehow? Yes, maybe. Observe that if you bring x-axis, draw a line parallel to the x-axis at this level, you get this angle as 90 degree. You already have this 30 degree, and this total angle is nothing but theta, right? So 90 plus 30, here theta is 90 degree plus 30 degree, that's what you can observe. And yes, it is 120 degree. Therefore, M is equal to tan theta, which is tan 120 degree. And for finding tan 120 degree, can you do that directly? Yes, maybe. But if you remember it directly, it is very good. But otherwise, you can use concepts of allied angles, which says, by the way, what is the value of this tan 120 degree? If you don't remember it, you should remember it. That this is equal to minus root 3. But how to find that? Minus 1 root, this is 180 degree minus 120 degree. I'll write it as this. And tan 180 minus 120, tan 180 minus 60, not 120. This is 120, which becomes this. 120 can be written as 180 minus 60. Now tan 180 minus 60 is the second quadrant. This becomes minus of tan 60 degree. And tan 60 degree is something you are well aware of. This is equal to root 3. So the overall slope becomes minus root 3. And yes, that is the answer for this question over here. That's the complete solution for this question. The 8th question says, find the value of x for which the points this and this are collinear. Now for collinearity, what are the concepts that you have? Let's take a look at the concepts. For collinearity, you have studied some things before, and you can use concepts related to that. If there are 3 points, let us say A, B and C, you can use distance formula, that is AB plus BC if equal to AC, then you can say that the points are collinear. You may use section formula as well. What does the section formula say? That if you can find some lambda for which the x coordinate of B can be found with the help of this lambda is to 1 ratio of AC, and similarly the value of lambda for y coordinate will be found if lambda for x and lambda for y are equal. Therefore, this particular point will lie on that particular line segment. Yes, and therefore you can say that the points are collinear. This is using section formula. Okay. What else? Third approach could be directly using the concepts of slope. So M of AB and M of AC. Can you observe that the slope of AB and slope of AC, if they are same? If they are same, then you can say that the points are collinear. Another approach could be using concepts of area of triangle. Area of triangle ABC, if it is 0, then you can say that yes, the 3 points A, B and C are collinear. That's another approach that you can follow with regards to this, right? And for area, you have x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y3 minus y1, the formula which you have seen some questions back, right? In the first question of this exercise, we have revised that formula, right? So any of these approaches can be used, but here we'll be using which of these approaches. So distance formula you have already solved, section formula you have already solved, the previous classes, area you have already solved. Here we'll be discussing using this concept of slope. Since slope is something new which you have learned for this exercise, let's deal with this question using concepts of slope. Let A x comma minus 1, B 2 comma 1 and C 4 comma 5 be the given points. This is be the given points, okay? And it is given that these points are collinear. Since it is given that these points are collinear, therefore M of AB will be equal to m of AC, or you can say m of BC. Is that okay? Yes. Will that make any difference? No, it will not make any difference, right? So m of AB, m of BC and m of AC all are equal, right? So this is okay, or you can write it as this as well. Now why am I using BC over here? Why not writing it as AC? You see, the vertex A has the variable x. Why write x twice? Why not write it only once, right? So we have done that. For slope of AB, you have y2 minus y1, which is 1 plus 1 upon x2 minus x1, which is 2 minus x. Don't make a mistake in writing this expression, right? This minus this, therefore this minus this will come in the denominator. For BC, you have 5 minus 1 in the numerator. So 4 minus 2 will come in the denominator. This is what you'll have. What is that? This is 2 upon 2 minus x, which is equal to 4 upon 2. This goes twice. Okay, so this becomes 2 simply. And what you have, 2 is equal to 2 times 2 minus x. This 2 goes, this becomes 1. 1 is equal to 2 minus x, or x is equal to 2 minus 1, which is 1. That is the required answer for this question. Concepts of collinearity have been discussed, and we have used idea of slope to find this x. You can also observe that any of these approaches, other approaches, will require more calculations than this approach. This is the latest one that we have studied, right? You can solve the question using 1, 2 and 4th approach as well. But this is the least calculation approach, and that's the complete solution for this question over here. 9th question says that without using distance formula, show that the points this are the vertices of a parallelogram. Okay, so if we wanted to use the distance formula, what you would have observed is this: A, B, C and D. If this is the case, then you could have observed that AB and CD will be equal, something of that sort, and BC and AD would be equal, something of that sort, and the diagonals will not be equal for a parallelogram. If the diagonals also become equal, then it becomes a rectangle actually, right? Parallelogram, a rectangle is a special case of parallelogram, and alternatively, right? You can also guess that. But no, we are not supposed to use that. We are supposed to discuss using some other approach, right? What is that? Without using the distance formula, show that the points this is. For a parallelogram, by the way, one very easy approach is using the section formula, right? And always, whenever you get a parallelogram, think of that approach. Here, we'll not use that approach, mind you, but always think of that approach. We'll solve this question using slope as well, right? So, but one of the approaches is that for a parallelogram, the only sufficient condition, necessary and sufficient, is diagonals bisect each other. For any quadrilateral, if the diagonals bisect each other, then you can say that it is a parallelogram, for sure, 100% sure, right? This is a simple approach. Another approach that we can follow is that m of AB, slope of this side will be equal to m of CD. Slopes of opposite sides are equal. They are basically, the lines will become parallel. The opposite sides have become parallel, right? And that's the property of parallelogram, right? That the opposite sides are parallel. This slope is equal to this slope, and m of AD is equal to m of BC. Both of these should be correct. That's another way of proving that the given figure is a parallelogram. That's another approach. So which of these will be we using? This one is pretty simple. You can always follow this approach. Let's mark the points on the Cartesian plane first of all. We have minus 2 comma minus 1. Minus 2 comma minus 1 is somewhere here. Okay. We have 4 comma 0, which is somewhere here. 4 comma 0. Then you have 3 comma 3, which is somewhere here. And you have minus 3 comma 2, which is somewhere here. Okay. So vertices are given A, B, C and D. Okay, this becomes AB, BC, and AD. This is what you have. So the vertices are given in a particular order. Yes, they are given in the anti-clockwise order. That's a good thing, right? And if you can prove using the first one, it becomes very simple. What you do is you find the midpoint of AC and you find midpoint of BD. So midpoint of AC, okay. Midpoint of AC will be 3 minus, x1 minus x1 plus x2 by 2. 3 minus 2 by 2 is 1 by 2. Okay. And this 3 minus 1, which is 2 by 2, which is 1. This is the midpoint of AC using idea of midpoint. What is the midpoint of BD? For BD, you have 4 minus 3, which becomes 1 by 2, x1 plus x2 by 2, and you have 2 plus 0 by 2, which is once again 1. Since the midpoints are exactly same, since the diagonals bisect each other, therefore you can say, yes, the given figure is a parallelogram using this idea. But then, NCERT people are lovely people. They want you to solve using this idea. They've taught you slope, right? Using this idea, you have already discussed parallelograms in the previous classes, but then this is the idea which has been discussed. Now, let's solve using the idea of slope. Okay, let's try to find the slope of AB. Let's try to find the slope of BC, M of AD, and M of CD as well, right? So, M of AB will be 0 minus of minus 1, which will become 0 plus 1 upon 4 minus of minus 2, which becomes 4 plus 2. This is 1 upon 6. What are you doing? You are doing y2 minus y1 upon x2 minus x1. What about slope of BC? You have 3 minus 0, y2 minus y1 upon 3 minus 4, which is 3 upon minus 1, which is minus 3. What about slope of AD? AD, you have 2 plus 1 upon minus 3 plus 2. y2 minus y1, this is 2 minus of minus 1, which will become 2 plus 1, and x2 minus x1, which is minus 3 minus of minus 2, that becomes minus 3 plus 2. This is 3 upon minus 1, which is minus 3. Pretty interesting. M of CD is y2 minus y1, 3 minus 2 upon 3 plus 3. y2 minus y1 upon x2 minus x1. This is 1 upon 6. Okay, can you observe that these two slopes are equal and these two slopes are also equal? Since M of BC is equal to M of AD and M of AB is equal to M of CD, this implies that the given figure is a parallelogram. The given figure is a parallelogram. That's what you have. That's what you can observe, and that's a complete proof of this question over here using this idea of slope, right? That's a complete solution of this question. The 10th question says that find the angle between the x-axis and the line joining the points 3, minus 1 and 4, minus 2. Okay, angle between. So you are supposed to find the angle between two particular lines somewhere there. X-axis and the line joining the points this and this. Okay. So 3, minus 1 and 4, minus 2. Let's try to draw the diagram first of all. 3, minus 1 will be somewhere here, and 4, minus 2 will be here. Pretty interesting. This is A, which is 3, minus 1. This is B, which is 4, minus 2. Okay, and joining these two will give me further extension. And where will this intersect the x-axis? This will intersect the x-axis at some point P, let's say. Okay, this is x-axis. And if you are supposed to find the angle between x-axis and this line segment, this line basically joining these 2 points, you are supposed to apply concepts of angle between 2 lines. What are the concepts? Let's discuss the concept first. For a line having slope m1 and another line having slope m2, if this is the angle theta, then this particular angle will be pi minus theta or 180 degree minus theta, right? This will be pi minus theta or 180 degree minus theta in whichever units you are comfortable with, right? This is what you'll have. And tan theta will be equal to m1 minus m2 upon 1 plus m1 m2. This is the formula which you have derived in the NCERT. If you can go through the proof over there. But this is the formula that is required. If you take the modulus, this will be a positive value, okay, and theta will be acute in that case. So one angle will be this acute angle, the other will be obtuse in that case, and the other angle will be 180 degree minus theta. From here, you can say that the angle will be theta and 180 degree minus theta. Both the angles are there, right? Both the angles will be correct. So angle between 2 lines can be found using that idea. So for that, I'll need slope of this line first of all, m1, And slope of the x-axis is something which is very simple, right? You should be aware of that slope. Since the angle made with positive x-axis is 0, this is tan 0, which is simply 0. And next we can find the slope of this line. This is m2, let's say. So let's find m2. m2 will be y2 minus y1, which is minus 1 plus 2. Minus of minus 2 becomes this 3 minus 4 in the denominator. This becomes 1 upon minus 1, which is simply minus 1. This is what you get. Okay, m2 is minus 1 and m1 is 0. So after this also, I have a simpler approach for you. What is that simpler approach? We can use this formula, right? We'll use this formula. But before we use that formula, can you observe that this slope of minus 1 implies that this particular angle is known directly. How is it known? Because this slope implies that it is the angle, it is for this particular slope, you know that this theta, this tan theta will be equal to minus 1. Since theta is the angle made with the positive x-axis, therefore tan theta will be equal to minus 1. That is the slope, right? That's the concept of slope. So if tan theta is equal to minus 1, when is tan theta equal to minus 1? If you can guess that directly, it is in the second quadrant and theta is equal to 135 degree. If you can guess that correctly, then it's okay. But then using the basics also you can deal with it. And how is that? Minus of, for 1 I know the value. 1 is for tan 45 degree, right? This is tan 45 degree, okay. And this becomes equal to what? Tan 45 degree can further be done as 180 minus 135, yes. This can be done as 180 minus 135 and after that this will come out. So this will become tan of 180 degree minus, it can be written as this as well. Since minus has to be brought inside, this can be written as this, right? Or you can imagine this written as this, right? That's what you can do. So this becomes tan 135 degree and from here you can guess that theta will be equal to 135 degree. Okay, theta will be 135 degree, pretty interesting. The other angle, this one will be 180 minus theta, which is or 45. The other angle, this is theta 1, this becomes theta 2. Theta 2 becomes 45 degree. That's what you can guess, right? Those are angles made by this line with the positive x-axis, with the x-axis in general, right? But if you have only found the slope and you want to use concepts related to this, what you can do is tan theta is equal to m1 minus m2. Now m1 is 0, m2 is minus 1. Let's use this idea. Tan theta will be equal to m1 minus m2, 0 plus 1 upon 1 plus m1 m2, which is 0. And the modulus will give me 1. So tan theta equal to 1 implies theta is equal to 45 degree is one of the angles. And the other angle will be 180 minus 45, which is 135 degree. That's the other approach that you can follow. This is for this particular question, you can guess the angle very easily. But in general, this is what you use. Right? In general, for finding angle between any two lines, this is what you use. Right? This is the result. This is the concept that you use for finding angle between any two lines. That's the complete solution of this question, as you can see behind me. The 11th question says that the slope of a line is double of the slope of another line. Okay, slope of one of the lines is double the slope of another line. If tangent of the angle between them is 1 by 3, find the slopes of the lines. Pretty interesting. A concept which you have just discussed has come back again in front of us. So what will we do in this case? So angle between lines can be dealt with very easily. Angle between lines is given by tan theta equal to m1 minus m2 upon 1 plus m1 m2 and its modulus, right? So angle between the lines will be theta and 180 degree minus theta. Okay, the slope of a line is double the slope of another line. So it is given that m1 slope of one line is double the slope of other line. That's what is given, right? If the tangent of the angle between them is 1 by 3 and it is given that tan theta is equal to 1 by 3. Find the slopes of the line. m1 comma m2 are unknown. Can you find m1 and m2? That's the question. Find the slopes of the lines. Right? How will we do that? We'll apply this formula and see where does that take us. So we have m1 which is 2m2. So 2m2 minus m2 upon 1 plus 2m2 times m2. This is m1 minus m2 upon 1 plus m1 m2. This modulus is equal to tan theta. Okay. and this tan theta is further equal to 1 by 3. Okay. If you remove the modulus, what you get is plus or minus 1 by 3 over there. So I'll solve 2m2. Let's simplify this first. This becomes m2 upon 1 plus 2m2 square is equal to 1 by 3, or the same expression m2 upon 1 plus 2 m2 square is equal to minus 1 by 3. Okay, and let's solve these two parts separately. This gives me 3m2 will be equal to 1 plus 2m2 square, or this tells me 2m2 square minus 3m2 plus 1 is equal to 0. Using concepts of quadratic or simple factorization, you see that 2 minus 3 plus 1 is 0, right? So substituting m2 is equal to 1 will give me a 0. m2 is equal to 1 is a solution. And the other solution can be found by using c by a. The product is c by a. So 1 by 2 into this. The other value will be this. So you can also observe that this condition is being satisfied. m2 is equal to 1 or 1 by 2. Are we getting two values over here? Yes, these are the two values that we are getting over here. Let's try to find values over here as well and see where does that take us. So this becomes 3m2 is equal to minus 1 minus 2m2 square. And this tells me that 2m2 square plus 3m2 plus 1 is equal to 0. One of the values that you can clearly observe will be minus 1. Can you observe 2 minus 3 plus 1 is 0. This is minus 1. And the other value will be minus 1 by 2. So for m2 you are getting 4 possible values. That's pretty interesting. For m2 you are getting 4 possible values. And if m2 is equal to these 4 possible values, then m1 correspondingly will be equal to double of this. If this is 1, this becomes 2. This is half, this becomes 1. If this is minus 1, this becomes double. That is minus 2. This becomes minus 1. Can we also check these values? Because it seems so that, okay, these may be the values of m1 and m2 also. So let's see. If m2 is equal to 1, first find m1. Therefore, m1 is equal to 2, 1, or either here also m1 will be equal to minus 2, minus 1. Right. So the pair of values for m1 and m2, m1 comma m2 will be equal to what? This will be equal to 2 comma 1. Or 1 comma 1 by 2. These are the possibilities, but we'll have to check whether all of these possibilities are correct or not. Let's check. This is minus 2 comma minus 1, and then you have minus 1 comma minus 1 by 2. We'll check first. Let's pick up this 2 comma 1. Let's check. Getting many answers. Let's check. For 2 comma 1, this becomes 2 minus 1, which is 1 upon 1 plus 2. Okay, 1 upon 3. That seems okay. 1 upon 3, that's tan theta. This seems okay. Let's check for 1 and 1 by 2. This becomes 1 minus 1 by 2, which is 1 by 2. And this becomes 1 plus 1 by 2, which is 3 by 2. 1 by 2 upon 3 by 2 is once again 1 by 3. This seems okay. And okay, you'll get extra minuses, and this also looks okay because you'll at max have a negative in the numerator. In the denominator, you'll have the same thing, and that negative will be taken care of by that modulus. So this also seems okay. And yes, at the end of the day, you get 4 possible pairs for m1 and m2. m1 comma m2, you get 4 possible ordered pairs. And yes, this is my answer for this question over here. That's the complete answer. Yes, that's the complete solution and the final answer for this question, as you can see behind me. The 12th question says that a line passes through x1, y1 and h comma k. If slope of the line is m, show that k minus y1 is equal to m times h minus x1. Okay, line passes through x1, y1 and h comma k. Can we solve this question very easily? Yes, we can solve this question very easily. The simple idea of something related to equation of a line. But then by the exercise 10.1, you haven't studied equation of line, right? So what concept can we apply over here? If a line passes through these 2 points, there are 2 points given, x1 comma y1 and h comma k, and slope is also given. Okay, so what is slope equal to? Slope of the line is equal to y2 minus y1 upon x2 minus x1, which is k minus y1 upon h minus x1. And what does that give me? This is m times h minus x1 is equal to k minus y1. This is what we wanted to prove, right? A pretty simplistic, a very simple question for that matter, yes. But on the basis of this, in future, you will derive the equation of a straight line. Equation of a straight line passing through some particular point and having some slope, you will find the equation of a line. You will find the equation of line using this idea. This is also called the point slope form of equation of a line. This is what you will be dealing with later on. But this here is a pretty simple question and simple application of finding the slope of line joining any two points, right? The 13th question says, if 3 points this and this lie on a line, show that this is equal to this. Let's see, if 3 points lie on a line, basically these 3 points will be collinear. Okay. And if the points are collinear, it is given that the points are collinear, we can apply concepts of slope, right? Slope of AB will be equal to slope of AC, which will also be equal to slope of BC, right? So we have points over here, let's call them A, which is h comma 0, B, which is A comma B, and C, which is 0 comma K. Let's pick up these 3 points, right? And let's apply concepts of, since these lie on a line, therefore m of AB will be equal to m of BC. Okay, we'll use H, AB and K as well. What does that give me? This tells me m of AB. We could also have used AC, that would have been simpler. Should we use AC instead of BC? Yes, let's use AC instead of BC. Right? Oh, since there are a few zeros over here, right? That's the only idea. We can use B only once. So we have m of AB, which is B minus 0 upon A minus H. And m of AC will be K minus 0 upon 0 minus H. This is what you get. Simplifying, this further tells me that B upon A minus H will be equal to K upon minus H. Let's simplify. Minus BH is equal to AK minus HK. Let's bring the terms having A and B together. This tells me that HK will be equal to AK plus BH. And now let's divide throughout by HK. Since you need H and K in the denominator, this becomes 1 is equal to A by H plus B by K. This is what we have, and that's a complete proof of this one, right? If you are aware of something called a particular form of equation of line, which is the intercept form of a line, if you are aware of that, then you may guess that yes, this question is directly based on that intercept form of line. But this is the proof of this particular question. That's a simple idea? Yes, that's a simple idea. The 14th question says, okay, we are given a graph. Okay, some population versus years graph. The population is increased. As we go towards the increasing years, the population is also increasing. Okay, population is in crores and this is years, right? Right. Seems like graph for India, I suppose, maybe. But consider the following population and year graph. Figure this is figure 10.7 directly from the NCERT. Find the slope of the line AB. Okay, this looks like a straight line. And using it, find what will be the population in the year 2010. Okay, let's try to do that. So, let's denote values on the x-axis, and since we have values on the x-axis in terms of years, this is years and this is populations over here. Okay, and this figure is not up to scale. There should have been this kind of a symbol over here. Let's see, just a minute. This kind of a symbol over here. Okay, and this is a kind of symbol that should be over there. Since this is starting from 1985, 1990, this is 5 unit, but this is not 5 unit, right? So the graph has been curtailed over there, right? Following population and year graph. Let's see. Find the slope of line AB. For finding the slope of line AB, what do we need? We need y2 minus y1 upon x2 minus x1. That is, y2 will be 97 and y1 will be this 97 minus 92 upon, you have 1995 minus 1985. This is what you need. What is that? This is 5 and this is 10. This tells me that slope of AB is equal to 1 by 2. That's my answer for this. This is the first part of this question, mind you, where you are supposed to find the slope of this AB. The next part says that guess the population in the year 2010. So for the year 2010, let's see if this line is extended. If this line is extended in this manner, in the year 2010, we'll get some population, right? We're not supposed to, we are not sure of that, but can we find that population? Yes. This point will be 2010, comma, population in that particular year. Let's call that, denote that by P, denote that variable by P. Right. And now we can apply a simple condition. What is that condition? That the slope of AB and slope of BP will be same, right? Since these are collinear. So M of AB will be equal to M of BP. Let's apply that. AB, the slope we have already found, this is 1 by 2. What is M of BP? What is that? P minus 97 upon 2010 minus 1995. This is what we'll need, right? And what does that give me? This tells me 2010 minus 1995 is 15. 15 comes over here. This is 15 by 2 is equal to P minus 97. And this tells me P is equal to 97 plus 15 by 2, which tells me P is equal to what? 97 times 2 is 194 plus 15 is 209, right? 209 by 2 is what I get. 209 by 2, or you can say that P is equal to 104.5 CR. CR is crores, right? Since the population is in crores, this is 104.5 crores. This is the final answer for this question, as you can see behind me over here. With this, we come to the conclusion of this particular exercise from the chapter Straight Lines for you. Till the next session, all the best.